Are you satisfied with your understanding of sustainability? If you are not, imagine a journey together, a pluralistic one, with academia, innovators, startups, NGOs, all looking for solutions to the greatest challenge of our time. My name is Samuele Tini, and this is the Sustainability Journey.
Welcome to another episode. Today we are going to discover something that at first when I read it, my mind was like, wow, we need to discuss it. We have and it's about something special, space solar, mind-blowing thing. And when I went researching, I found that we have an important part, our energy transition. We have discussed it in other episodes, and solar and space solar can be one of the answers and one of the pioneer technology to solve our needs. So I went researching and I found, I think, one of the leading experts in the planet. So Martin Soltau, who is the co-CEO of a company called Space Solar. So Martin, thank you so much for being here with us.
Samuel, it's a pleasure to be on your podcast.
Space solar. It's something that at the beginning I was like, what is it? I need to know more. But before that, before getting your insight as a world expert on that, we want to know a bit more about you. Who is Martin? What is your journey to sustainability?
Yes, sure. So I'm an engineer by background and training. I've been in the aerospace sector all my life, leading major programs, business leadership, and my journey in space solar power started about 5 years ago. I was heading up the business for a consultancy in the UK, Fraser Nash Consultancy, and realised that the government really needed to look at these more capable technologies if we're going to get to net zero. And the UK is one of the leading nations really pursuing the energy transition with a very serious policy and a lot of investment in technology, wind, solar, nuclear, and others. But it's very clear that even that is not going to get us to net zero. And at the same time, I have a strong interest in space, and I've realised that space-based solar power is actually becoming a lot more technically and economically viable. And so we ended up doing a study for the government in the UK, which I directed, and the results of that were much more optimistic, particularly on the economics, than anyone thought. And so that's how my journey started on this 5 years ago.
Fantastic. And we want to know everything because when I first read it, what is about? And I think as 99.9% of our listeners, we want to know more about what is space, solar, and the solar-based energy. So, can you explain a 101 to us how it works? How this can contribute to the global energy transition?
Yes, certainly. So first, it's worth saying a note about our energy systems. Much of the world is looking to wind and solar for the bulk of the clean energy of the future. But of course, as we all know, these are very weather dependent, they're intermittent, and so you need backup forms of energy to make your energy reliable. And it's also really important to have affordable, cheap energy. It's the lifeblood of civilization, and particularly important for those nations which are kind of on the development pathway. Really, really important because they're going to be growing in their energy needs massively, and they can't just get do with it. So space-based solar power is the concept of you harvest solar energy in space, where firstly the solar insolation is about 40% more than the absolute maximum it is on Earth. If you stand in the desert at midday on the equator, you get about 1,000 watts per square meter. In space, it's nearly 1,400 watts per square meter, and it's like that all the time. There's no night, there's no weather, there's no atmosphere. And so if you put a solar panel into space in a high Earth orbit, you can harvest 13 times the amount of energy that same solar panel could harvest in Northern Europe on the Earth. And that really underpins the why of space solar power, and it also underpins the economics of it. And so in the concepts that most organizations around the world are pursuing, they're very large satellites with acres of solar panels harvesting gigawatt scale, and then it's converted to microwaves, which is high frequency radio waves, and beamed down to Earth in a coherent collimated beam, just like a radar, to a ground receiver called a rectifying antenna, and that converts the microwave radiation back into DC electricity, and then just like with terrestrial solar, it's fed through an inverter and into the electricity grid as grid scale electricity at the sort of gigawatt level. So a gigawatt is enough to power 1 million homes. It's a substantial amount of energy, and all of this technology, or all of the components of this, the photovoltaics, the ability to convert that and form these energy beams, is all today's technology, and indeed at the right sort of efficiencies. What hasn't been done is to build them at this incredible scale, and to do that in space at this sort of scale.
Wow, so if I have understood correctly, solar system put in space with 40 times the efficiency that we can have here at the equator where we are talking right now, and beam to Earth. So and empowering houses and as a source of clean energy with no nights, no issue, no dust, no clouds, all the things that we have to do even at home when we have to clean the solar panels every now and then to improve efficiency for our batteries. I mean, is it correct? And how you transmit? I mean, just to understand properly, we'll discuss more about the technology. Do you lose power when transmitting? How it works, this technology? And has been ever tried this transmission?
Yeah. So the benefits of this, firstly, it provides this continuous dispatchable power, which is essential for the stability and of the grid. Secondly, it provides this, so continuous power. Dispatchable power is really important. So that's about filling in the gaps when the wind stops blowing and the sun stops shining for the terrestrial renewables. This is providing that continuous reliable power, and that's absolutely essential. And then thirdly, because satellite can see a third of the Earth's surface at any one time when it's in geostationary orbit, it's a global system. You can be exporting energy when the wind is blowing strongly, and you don't need the space solar. It can be exporting, so it's not sat there idle. And again, this underpins the reliability and strong economics. And then to answer your question on how it works and are there losses? Yes, like any energy technologies, there are losses. If you take terrestrial solar, you get huge losses just of the solar energy coming through the atmosphere at night and things. And then the solar panels themselves are about 22% efficient and so forth. So you've got about 10% of utilization over the course of the year, and the efficiency is in that sort of order of magnitude when it is beaming. For space-based solar power, you get 100% utilization. It's working all the time, and there are losses in the conversion. So you're starting with solar energy, you convert that to electricity on the photovoltaic panels, then you convert that to microwave, and there's a kind of loss there, and then you convert it back into DC electricity, back into AC. So there are losses all the way through that chain, which we studied very in great detail in the techno-economic study for the UK government. But when your energy is free, as with the sun, the efficiency just means it's about the cost of the capex. It increases. If you've got a lower efficiency, it increases the size and the capex of the system, and so ultimately it's about the economics. The really important thing is you're getting continuous energy, 100% of the time, which is so important for our energy systems globally. And actually, when you compare it with terrestrial solar, the efficiency is quite a bit more. It's about overall end to end, from the sun to the plug. It's about 17 to 20%. That with terrestrial solar, it's less than 5% with all those other losses that I described.
Fantastic. And I want to know about this technology and understand you have now, when after the study that we will discuss with the UK government and we want to understand, you have moved ahead as an entrepreneur, a pioneer in that with Space Solar. So, how a company? What is the mission of Space Solar? Which is the vision that you have as CEO of the company?
Yeah, we founded Space Solar, dedicated to taking forward the development and commercialization at scale of space-based solar power, really for the benefit of all nations. Because this is a global system that can scale out and it really is applicable to developing nations, island nations. It really is it is going to be a global system. I go back to your introduction. It was a great introduction, and I think that's the first. Your reaction is the first reaction for most people. It's wow, surely this is a bit science fictiony. And so when we did this study, it came out really positive that about the techno-economics of space solar power. A colleague and I set up a coalition of the willing here in the UK called the Space Energy Initiative, and this was to get the conversation on a much more serious level. Rather than just being wow and curiosity, it was to get senior thought leaders, government, ministers talking about this as a serious solution for net zero and energy security. And so we've now got 90 plus members, big space and energy companies, National Grid, Airbus, Thales UK, KBR, big companies like this, and leading universities and the government, and increasingly international organizations, all really developing the right environment and ecosystem, particularly here in the UK, but very much looking internationally because this has to be an international program. Now, why we founded Space Solar was that we need a commercial vehicle to take this forward, to attract investment, to actually deliver a real program. And that's why we founded Space Solar. We've got great partnerships with many of these companies in the Space Energy Initiative and beyond. Got really strong support from the government. We're brokering international partnerships to make this possible, and we're underway with our engineering program, and we've got a very capable system concept. So yeah, when you think about developing something very disruptive like space-based solar power, brand new energy technology, it's going to provide energy in very different ways. We can reimagine the way the grid works. It involves power beaming, and that's going to be a technology that needs strong, societal conversations and acceptance and things. So there's a lot of work to do to explain to people, both in government and industry and the public, why this is a really important and it will be an essential component of our future clean energy.
Fantastic. I mean, a source of power, free, always up. It sounds like a dream. Us that we are battling still and try the energy transition and battling ourselves out of the fossil fuel dependence. And have you got some milestones for the company? We will discuss it more maybe in the future, in the subsequent of the episode. But I wanted to know which are the future milestones and when you will have something out there.
This has been studied for decades by NASA and others. This is not new. And there have been a lot of work on some very capable system concepts around the world by different organizations and leading engineers. So we're starting from that base of decades of work. And Space Solar has a really strong starting point. We have a Cassiopeia solar power satellite design, which for various reasons is one of the market leaders in terms of its economics and the way it performs. And we have a 6-year development program to get from where we are at the moment, which is a very, very well developed system concept with some small scale hardware demonstrations, to a significant demonstrator in space, a proof of concept beaming a megawatt of power from space to Earth. And so that's a pretty short timescale in the scheme of things, 6 years. And at this point, the government in the UK has said it will be strongly backing us with contracts for difference, which is their way of shaping the market and encouraging new technology. The major oil and gas companies, BP, Shell, and others have signalled they'll be putting it very strongly in their near-term plans and so forth. So there's a bit of a tipping point at that 6 years when we've demonstrated at that sort of scale. And thereafter, it's about scaling it up. So If you think of a nuclear fission plant, they're huge capital infrastructure, lots of civil engineering. It takes a decade in the planning, it takes another decade or more to build, and then you've got a two gigawatt continuous energy, not very cheap, and takes a long time. Space-based solar power is totally different. It's made of hundreds of thousands of small modules, perhaps the size of your dinner, kind of dining table, and so these are manufactured in factories like a bit like sort of Dell laptops or something. They're manufactured at huge scale, and so this does three things. Firstly, it means that the unit production cost is very low. It's getting towards consumer electronics type, not quite that low, but it's way low, orders of magnitude cheaper than space hardware traditionally has been. Secondly, it means you can scale this up very quickly. We can be building tens of gigawatts per year, not 2 gigawatts in 10 years, but tens of gigawatts per year. And so we can have a real impact on net zero. And thirdly, because all these modules have all of the functionality to collect, convert, and transmit the energy, it means the whole system is very resilient. So if you think any technology has challenges, and in space it's a harsh environment, micrometeorites and other failure modes and things. So if you have some of these modules fail, it doesn't matter because the whole thing goes on. There are hundreds of thousands, no single points of failure. So it's a very different in its architecture. It means that A, it's going to be very capable and resilient, and B, it's going to really make a difference for net zero globally.
Fantastic. I cannot wait 6 years to have 1 megawatt transmitter beam from space. And that will be a game changer. I totally understandable because we know that in project management, nuclear is the nightmare of any project manager in the world. So usually they are over budget, 20 years delivered 20 years later, and with huge risk. Not even environmental risk, social risk, and others. And talking about risk, you mentioned before, we need to educate the public, we need to educate government. I mean, I can understand because seriously, if you talk of solar space, they might think of a movie rather than a technology. And which are the key challenges that in developing space-based solar power, and how you are overcoming those?
Yeah, I think the first, in terms of the technical challenges, I think the first one is what we talked about, the scale of the systems. They're typically 1.5 kilometers in diameter or more, 4 kilometers long. They're huge structures, but actually only 5 times the mass of the International Space Station. So but nevertheless, because of this size, they're assembled in space with robotic assembly systems. They think about sort of Amazon warehousing sort of technology for the robotics. It's that sort of robotics, not some complicated kind of manipulator arms and things. And so that's the first thing. The power beaming is, whilst that's been demonstrated multiple times on Earth at the right sort of efficiencies, again, it needs to be scaled up in space, and there are lots of engineering issues to overcome, but crucially not laws of physics issues. They're just engineering issues which have got tractable solutions for. I think one of the timescale risks is the regulations. So this is technology involving power beaming, and you need international agreements on spectrum, and they typically take a decade or more to get those sort of agreements negotiated internationally. And we're trying to do this, to have an impact on net zero timescale. So, and then the rectangles are large structures, and whilst they are, typically think about 3.5 kilometers in diameter for a half to 1 gigawatts scale system, and so integrating those is considerable planning consideration for any nation. And in the UK, we've looked at it extensively and around Europe. There are some places onshore, but typically offshore is a pretty good location as well. And then finally, the public license to operate is really important, and we've been doing a lot of work there and engaging with the public. I have to say it's been really positive so far. People get that we can't get to net zero with just wind and solar. And once one explains why this is safe and so capable, it's been really, really strongly supported.
I mean, let us hope the red tape of the politician does not take 20 years to, to get the spectra, otherwise we will be all dead if we continue not moving our transition. But it's really interesting, and as all new technologies, of course, there is a lot of and the fast discussions and seeing all from the regulations for also, and I really like what you point out, the offshore. So that will use maybe existing I don't know if platforms or other that can be used for that space, also reutilizing what maybe was left.
Exactly. I think the thing is, it's not going to involve big industrial infrastructure in people's backyards, which is the big problem for planning.
Yeah. So that is something that is I can be a very easy and an easy win to get to garner public support. And I want to understand now, I mean, a step back. Before you have been at the forefront of one of the leading nations, the United Kingdom, in this study on the viability. And surprisingly, you mentioned to us that the economics is not just what was on an Asimov novel, but it's something tangible that in 6 years, that is like, and now we will see it on existing and beaming power from space. So which were the findings that convinced you and to go for the space solar and how also what was the reaction of the government on that?
Well, the government study that directed was looking at three things. Firstly, is it technically viable, or is the technology sufficiently mature that you could start a development program now? Secondly, is it economically viable? Will it actually produce electricity at a competitive price? And thirdly, it was because it was a UK study. It was, what are the economic benefits for the UK if the UK government invested in this? It's always any investment's got to have a strong benefit to cost ratio and stuff. And the answer to all of those three was a really, really positive. Yes, it is viable technically and economically, and really, really strong benefit to cost ratio and so forth. And the recommendations were to get going with a development, to look for international partners, recognizing this is a global system. And that, I think the reason I was motivated to set up Space Solar is that although we had broad support within the Space Energy Initiative, all of the members there, nobody else was willing to do this as their core focus. It needed a dedicated enterprise whose sole mission is to develop space-based solar power, working with partners and things. And that's really what kind of drove me to conclude that we needed to do this.
Fantastic. And I want to get a bit more in depth toward this role of the private sector. So I have read that also other players, if I read correctly, Airbus is coming on board and other companies, they are looking at the space solar-based power. So I want to understand because usually these things like the internet and others, they were the domain of the defense or the huge investment. So how do you see the role instead of the private sector to be, and which are also the advantages of having private sector led initiatives to foster technology?
Yes, it's a really important point. The financing of space-based solar power is probably our biggest challenge, and because it needs this 6 year investment, pretty substantial, and the time for returns is probably nearer a decade. The 6 years gets you this proof of concept, but then you've got to scale it up, and before you can get a commercial sized power station in hundreds of megawatts or gigawatts. It's just too long for the venture capital or even corporate venture capital. Airbus is a really, really important partner. We hope to be working more closely with them. They're pursuing nearer term things around the power beaming, which is of interest to them for a number of applications, particularly in sustainable aviation and so forth. So and other partners similarly are looking for those sorts of spin-offs. They're not really focused on the end goal of this sustainable energy, but they're looking more near term at the spin-offs. And the spin-offs are really, really important, particularly in space robotic assembly, power beaming and others. It will spawn new industries there. So I think our conclusion from talking to many investors is that governments need to come on this in a big way in the early days. It's a classic case of this nascent market. There's a strong market for clean energy. We all know that, and societal need, but it needs really strong government funding support.
No, fine. I think it's important we have private and public partnership, of course, to reduce also the investment at the initial stage, which, of course, I mean, I'm sure they are huge and has been a success story for many of the technologies, especially also in the past. So where government have produced and kickstart and then companies they have developed and put it at the commercial stage. Because I think the most important part, as you say, is commercially viable. We don't need a solution that can produce power, yes, but at 20 times the cost that power produced on Earth will not make any sense for net zero. But if it's commercially viable, that is something that has a stronger and a strong business case.
Yes, it's worth just, and it's a really, really important point. And the thing about wind and solar is that although their headline cost may be relatively competitive, actually as part of the system, it's quite expensive because you need the backup. So you're paying for your energy sources twice. And this is where space solar, as part of the mix, can really help to very substantially reduce the cost of our energy systems, because then you don't need to overbuild the wind and solar. It's not just running there in the backup as reserve. It's utilizing it 100% of the time because you're exporting when you don't need it and so forth. So it needs to be thought of as a part of a system that really makes the whole system cheap and reliable.
Yeah, because you won't need again the backup and the batteries, the one we have also at home, because at night we cannot go with the panels, they don't work. So that is the huge cost also for that's hindering also the development of solar, I mean, especially in the developing economy, because the cost is the batteries and the backup.
And of course, there's a lot of talk in the press about net zero and how we just need to build more wind and solar things. But this backup doesn't exist yet. The batteries at a sort of scale overnight and then seasonal, weekly and seasonal storage just doesn't exist. It's incredibly expensive, and it's got real environmental impact. So low density wind solar batteries take huge quantities of minerals and mining. And of course, mining is not an environmentally friendly activity. It's carried out in certain countries which are, may be challenging geopolitically, and it's refined in other countries which are maybe challenging geopolitically. So there are no solutions at the moment for getting to net zero in a properly affordable and sustainable way.
Let us hope in 6 years we'll have the answer, and a proven answer with space solar. And about the collaboration, because going back, you have seen that it's a collective effort, which everybody, and I hope governments, international organization, capital, and they will be all together, which are, and especially talking about the Space Energy Initiative, which are the impacts of this collaboration? Put it together, you mentioned some big names, from the utility, from the big oil and gas companies. So how this momentum is growing?
Well, I think we're hoping that the UK will catalyse the development programme. We want to bring in international partners both at the government level and commercial level. And we're reaching out to the best technology and partners around the world. And one of the important things is that this is an energy technology. It happens to have a big space component, but it's actually an energy technology. And so the involvement of the energy sector is really important here. And because it's a global system, these systems will work best as in global partnerships. That's why we need global regulation, global collaboration and partnerships with governments. And the UK is a good starting point, partly because we've got the energy and space and science and trade departments all really joined up and supportive of this. So secondly, the UK is naturally very collaborative. It has strong instinct to reach out for international partnerships and things. And it's a pretty good place to invest and do business. And so we are collaborating with the government to reach out for those partnerships. But we need to get going now because net zero is not waiting. And so we've launched our development program. And yeah, hoping that it will scale up and we'll get those partnerships and funding.
Fantastic. And talking about this partnership more, you have been also, you are an expert in aerospace, energy, and especially in aerospace. Because one thing as a lay person in that, I mean, I'm totally ignorant about any engine, I mean, sophisticated engineering, let alone space engineering. I wonder, how do you see this industry evolving? So, for example, for me, okay, when reading, I say, wow, I mean, we have seen now starships moving. So, how this can put a payload of so big that, for example, you say acres of solar panels, how these technologies can work, and how do you see the future on that?
Yeah, I mean, you mentioned Starship, but that really has been an enabler. Reusable launch has absolutely been the one thing that's meant that space-based solar power is now economically viable. And great, we had the integrated flight test of Starship yesterday, the third one went orbital, fantastic. It won't be long until they've got that operational, and we're talking very closely with SpaceX on to make sure that our roadmaps are aligned with theirs on Starship. But we'll bring in other reusable space capability as well. We can't just rely on one player. So how this will play out industrially, I think, is really interesting because firstly, you've got as an energy system, you're both generating and transmitting energy. And so there's going to be differences in the way the energy markets work. Suddenly you've got this incredibly capable energy, which is capable of being transmitted much nearer to the points of demand. So I think there are going to be changes in the energy sector and utilities and generators, and people will play in different parts of the value chain there. And in terms of the space segment and things, again, it's going to spawn new industries, particularly in robotic assembly in space, which is absolutely going to spawn the next economic revolution. Once we can build large structures in space repeatedly, reliably, with all the right regulations in place so that it's done sustainably and responsibly, that's going to be an absolute game changer. And so there's definitely some players there who are already starting, but it's fundamentally, I think what this does is to move all of these small scale research initiatives and startup companies who are doing some great innovation, but just at a small scale R&D project with government backed R&D. Suddenly there's this huge energy market, and there's going to be a market pull for these capabilities, which has hitherto not existed. So there's a lot of interest in, for example, being able to do active debris removal in space, which is, if it grows, if debris grows, it really threatens our ability, humanity's ability to use space. Who's going to pay for it? There's no market model there at the moment. While space-based solar power provides you can see the sort of way that might provide a market model for why we get good at cleaning up our space environment. So yeah, really exciting. I think the market and industrial structures are fascinating.
Well, Martin, I mean, listening to you, so you see there is, I would ask this question. I mean, in the next decade, can you see that? You may want to say that we have finally find a solution that can solve our energy problem. Is it a bold statement, or is something that we can say certainly that is the way? And I understand what you said. I mean, it can be massive transformation, also the debris, the work, the robotics. So it will be a game changer even for our economies and the way we think about industry and production.
Yes, completely. It will. And we can definitely say that. It is absolutely going to be game changing. And internationally, there are some very exciting initiatives in Japan, China. The US military have been looking at this quite a bit. Even parts of NASA have been looking at it quite carefully. Korea and others. And this is really now going to accelerate. I mean, it's really only 6 or 7 years since reusable rockets really started to become a thing. So this is why it's all quite new. It's kind of been there waiting for this breakthrough of reusability in the launch. And so yeah, it's definitely going to be there. It's going to be space-based solar power is going to be a game-changing clean energy technology decades before nuclear fusion, which is still in the kind of research and understanding the physics area.
I want to ask a question. You mentioned that China, Korea, Japan, US, UK, and I'm sure maybe the EU and other government, is there, I mean, as a lay person, again, totally new on this field, is there a way we can have it a sort of humanity collaboration rather than a race to space?
Yeah, there are important ways we will definitely need to collaborate, and particularly around the regulation and standards to make this possible and the market shaping aspects. That's critical. I think if it becomes a government-led collaboration to develop the technology, it will take decades.
Yeah,
that's our
50 years minimum. 50 years minimum.
Yeah, this is the challenge. So this is why we feel strongly that this does need to be a commercially led program that's going to give returns to investors, that's going to attract private investment as well as public, but working very closely with governments and public sector. So it's a classic best of both model.
Yeah, definitely. And let us hope also that there is a pool of work and funding to really put this at scale. And I'm sure I totally sort of understand that primarily led innovation, faster deployment to market, and of course, I mean, cutting all the red tape and bureaucracy and having something, I mean, in 6 years, if you can beam 1 megawatt from space, it will be, I mean, I think, a game changer. And we are all waiting for 2030 to see if it, and I'm sure even with the poster, we'll come back and see, check on you. I mean, if not, I will be say, wow, I found a new reason of and a new line of work for me, really fantastic and really a game changer really for everybody that has been in sustainability, try to fight for net zero for all these years, for the past 20 years. And for the people like me that's and others that they are not at the forefront of sustainability like you, a pioneer. We can say that Martin, maybe you will be in the history books where we will read about the inventors, maybe in 200 years, the first people that studied and made the viability of space solar, and we'll read your name. So from your perspective as an innovator, a change maker, which advice you give to young professional entrepreneurs that they want to do something sustainability?
Yeah. Well, thank you for your comments. I think we stand on the shoulders of giants that have gone before us. So and there are many people who've done a lot of the early thinking. I think I would say to young people, give it a go, follow your passion, and give it a go. Be entrepreneurial. There are some really exciting things that are happening in the world. There's a lot of technology coming along that's going to be really improving our world, making it more sustainable, addressing the big challenges of biodiversity, clean energy, climate change. These are challenges that are solved by people who have a passion and knowledge and engineering know-how and broader skills. But it's a super exciting and positive outlook, I think, for humanity, and go for it.
Fantastic, Martin. And it's really like what is about also the podcast, bringing change maker and solutions for our problems. So, Martin, I have no words to thank you for this such an insightful and episodes, and I'm sure everybody now knows an awful lot of more content about space and why it's so important about our future and our net zero objectives. So thank you so much, Martin. It's been a pleasure.
Thank you, Smurley. It's been an absolute pleasure.
Are you satisfied after this wonderful episode? Let's continue together our sustainability journey.